586 is used on rotors across the board still. Lots of different applications out in the field that already have the MG586. You have the manual on your memory stick. It's W458 200 is the generic manual. You also have a special calibration procedure on your tech notes that I gave you, and it's called BMC calibration, because theirs is a little bit different than others. So, but that W458 200 is perfect for a generic 586 system, be it a Terex or a Manitex or whatever other crane, Elliott, all of them, they calibrate the same. So this is an extremely simple system. Very, very simple. There's not a lot to remember, there's not a lot to do, and most of the calibration on it is going to be automatic, okay? And like I said yesterday, in my opinion, this is the best tool the small crane operator ever had, because it gives him all the advantages of the RCI 510 without having the big expensive display. So there's a little history to this. Way back when Terex first decided to put the Greer system on their boom trucks, they purchased the MG585, which was this display you see right here, which didn't have all these different informations on it. And that first display was installed back in 1999. Some of the things that were undesirable was the fact that you had a menu on here that you had to compare with a placard on the mainframe. In other words, you'd roll up a number in the little window for the setup and then match the number to the placard to see what your setup was. And later here we changed all that. So by the fall of 2001, you can see we're going to have a bunch of these 585s already out in the field. And Terex was talking to their customers, and that's when they came to us and said, you know, our customers want more information on this display. And they were getting a lot of complaints about that. So we went to work on this, and we developed the MG586, which had the larger windows with the nice information outputs. So on this system, it's very basic. We have a computer, the display, and our reeling drum, and a 2-block switch. This is the super switch. Terex uses the big 2-block. It's the same thing. It's just a continuity circuit. On the MG585, I don't remember if I didn't put any point outside. You can see here, this window right here contains the load, intense. You have your moment bar, which tells you where you're operating, the green status light, your ATB signal, and a red overload light when it goes into overload. Now, all Greer systems work the same as far as function cutouts. It's going to cut out any function that will worsen the condition, okay? That's going to include extending out, booming down because it increases the radius, or getting the load higher off the ground. All those things are included in a function cutout. Now this is the portion of this that people, I was telling you, didn't like, because you would hit this setup button and roll these items up into the window, and then turn around and compare that to the chart on the mainframe. And it would say like, oh, boom with jibs towed or something like that. What the 586 did for that was to put those menus into writing on screen, which people just really like. So with the introduction of the 586, we now had a display that has multiple screens to work with. And we have one screen up here for setup codes. This is like 1, 2, 3, 4, 5 codes. You have a setup button that you use. You just push the setup button and it goes into the setup mode. And then you use the the up and down arrow keys to the select buttons to roll through the menus, okay? And the menu will come up on this large information screen and show you the configuration that you're searching for. Now you can see there, this window here shows boom angle, and we ran out of room here, so there's a toggle. If you hit the up arrow button or the down arrow button, this will toggle to length, boom length, okay? They took a poll with the different crane people that they were working with, and 100% across the board, the request was give me boom angle as you know, to show up all the time. So the screen always comes up in boom angle. If you want to see the boom length, press the up arrow button and it'll change to boom length for you. And it'll hold that on there until you change your mind. You're going to display your radius in feet and tenths, your load in pounds. In this upper window, I'm not keeping up with my arrows here, am I? Your contrast button will contrast the background to what you're doing. Maybe you're working at night or something and need more backlighting. A cancel alarm. The cancel alarm button in this application, any 586 application, the cancel alarm button pushed once will cancel the audible alarm. Okay, it'll turn it off. As long as there's not another overload or two block condition shows up, it will stay off. If you press and hold it, it will reconnect the function kickout relay and allow you to move the boom as long as you hold the button. Okay? Some other systems will lock that out and keep it locked out. This one will not do that. You have to continually hold the cancel button if you're going to move the boom while it's in lockout. We have our hook load in pounds. Now remember, on all Greer systems, hook load means everything under the head of the boom. That's what it means. Everything else is boom moment, okay? So everything under the head of the boom is going to appear on this screen, and the tolerance on that is plus 10%. We will go 10% over on the displayed load. We do not like to see anything under. We never display the load short. The moment bar, this is kind of hard to see here. You can see this liquid crystal kind of wanders out across the screen. We have a reading up here, which is maximum load, right off your load chart, including deductions and stuff. The ATB light, which comes on in the event of an ATB condition, and will also turn on function lockout. And the 90% capacity alarm, or the yellow, and the 100% capacity, also causing function kickout. So these are the neat new things that we added into this 586 that everybody got all excited about. And when this happened, you know, Terex just stopped in their tracks and said, you know what, we're putting that on all of our boom trucks across the board. That was like history. So let's move on to the computer. This is a Generation 1 computer. This is a 600 series computer. And notice that this has the wiring connectors coming out at the bottom. It's not the RT style computer. It has the little plug-in connectors in the board. So you put the wires into the plug-in connector, tighten the screw on them, and then push them in. And sometimes, you know, you might have a situation where you might have a loose wire in there if you're troubleshooting a problem. And let's see, this talks about serviceable parts again, which the system chip goes into this socket. It is always a serviceable item. The internal transducers, these are programmed to the board, cannot be changed in the field. There's a COM indicator right here in the bottom, the part of the board. That's a flashing indicator. I've had countless calls, somebody saying, well, I found the problem, the light's flashing. Well, it's supposed to. It flashes for two-way communication. That's what it's doing. The FKO fuse, just a standard 10 amp fuse that supplies power to the function kick-out circuit. And power supply indicators. There's 4 green LEDs right up here in the corner. I wish I could have shown those lit up. I never thought of it. All 4 of those LEDs should be lit. That's an indication that all of these internal power supplies are working. This computer has several internal power supplies here that supply different voltage levels for different functions. Again, those are non-replaceable, and they are indicated by these LEDs. Okay. Another thing you might remember, if you see a 5-volt LED that's out in this location up here, one of these is marked 5 volts. If that is out, something that will cause that would be like a short in your reeling drum harness where it takes it to ground. If something takes that signal to ground, it's very easy to delete that 5-volt signal and cause that light to come on. So maybe a good way to troubleshoot that might be to go right over here and just disconnect the wiring harness to the reeling drum and see if that power comes back. So, other than that, I don't think I've ever used these LEDs for anything. That's been the experience with 15 years worth. So it doesn't happen very often. So the connection between the crane and the MicroGuard system. You've probably seen the big MetroPack computers that Terex puts on the RTs. It just has 2 large square connectors, and their wiring harness is built into the crane. When they take these boom trucks and marry them to the truck, the situation's a little different, and they have to furnish a custom harness. So we make that a plug-in harness, and Greer Company furnishes these harnesses coming out, and Terex furnishes the harnesses coming from the truck. So in order to cover all that, you can go to our computer schematic that I gave you, our assembly schematic, which shows the internal hookup on the computer, but you have to go to the Terex schematic to get the rest of the hookup. Or the Broderson schematic. I also included for you a Broderson schematic in there. So on these harnesses, the left-hand harness is always the power and the FKO. So you're going to have an incoming power from ground and 2 wires coming out. One is for the function kick-out solenoid. The other one is for the warning horn. So, and that switches by this internal relay, which also is built into the board. You have your display harness, which furnishes power and ground to the display, and also 2 communication wires, one for communication going out, one for communication coming back. Because this, I don't know if you're familiar with this 2-way communication, but basically what we do, we have a COM-A wire, which sends information out to the processor and the display, delivers the information, and waits for the display to respond back, saying, okay, I got it, and posts it to the display. So that's the 2-way communication thing. The reeling and ATV harness, this wiring done inside the computer will be on your computer schematic. The other part of that, you can go by your voltage cards that I gave you, okay? That color code on that voltage card is perfect. It has never changed since I've been with the company. Hopefully never will. Same colors. So, way back when they first initiated the MG585, Terex had an electrical box inside their crane pedestal that looked like this. And in this electrical box, they had relays in there that controlled the power between the crane and the computer, okay? because Terex used to have in there what was called an electronic capacity alert system. And in this box, there was a little set of LEDs and a little computer board that only sensed pressure. So when they decided to go with a load moment system and the Greer computer, they decided to leave this circuit breakers and power relay and the 2-block relay into this electrical junction box over here. They installed the Greer computer on the other side and hooked up the hydraulics. And see this, we ran the wiring harness here directly to the reeling drum, and the power and function kick-out harness went into their relay box, okay? And I'm getting ready to go into something here, so I'm up to something, look out. So that inside of that relay box looked kind of like this. You know, you had a relay here that furnished main power when you kick the PTO in. You have a truck shutdown relay that connects and disconnects the fuel solenoid, and circuit breakers for the outgoing power signals. That was all in that junction box. Well, at a later date, in about 2000 something, Terex came to us again and they said, you know what, we would really like to have this power box consolidated with the computer, okay? So the engineers got their heads together and they come up with what we referred to as the 500R computer, which meant that it had internal relays. That started off with this part number, A45655, and you can see down here in the bottom you have the red circuit breakers and 2 relays that took over all of the signals out of that power box, okay? So about that much of that computer became this relay box, okay? It doesn't do anything to the actions of what the load moment system does. It just shares the incoming and outgoing digital signals. So here's a little close-up shot that shows the circuit breakers. This is showing 3 green LEDs on the board here, and one of these LEDs matches each circuit breaker. So if you get inside there and you have a light out, one of these circuit breakers is not working, and it's pluggable, replaceable circuit breaker. You have your main power relay here, which for the most part, I think they just connect that with a ground signal to the PTO, so that when you kick the PTO in, it grounds the leg on the relay and brings battery power into the computer, dumps it right into the computer bus. The stop relay is always wired normally closed and only opens with a power signal from the switch on your console. So that dumps your signal to your fuel relay. Okay, so those were the new additions to the computer itself. Everything else is standard on the computer. You've got your EEPROM in there and all of your control items for the computer and your transducers. Same way, it's all programmed into the board, and you can't change the transducers in the field on that either. Okay? Any questions on that? Does that make sense? So you know the reasons all this stuff was done. So moving on to that, we'll move right on to the reeling drum portion of that system. And on this, I'd like to remind everybody that pretension is important. And here's the steps, you know, with the cable wound on the drum and dead-ended or whatever there, you turn counterclockwise 5 complete rotations for preloading the spring. And then physically prevent rotation and remove enough cable to reach the boom tip. And there's a little tip there. 3 wraps of cable on the drum is equal to about 10 feet. So if you've got a 30-foot boom, then you're gonna take off, what, 9 wraps? Sounds about right. So you take the cable off to reach the boom tip and protect the 5 turns of pretension. Looking into the face of the reeling drum here, we can see the sensors in there and our two block situation here with the wiring and the collector ring. And we have the angle sensor over here. You can see it's mounted into its sensor plate. At the factory, we will take and mount this sensor plate to a machinist manual, okay? And you crank the angle on this, and we set this up to where when the boom's at 0 degrees, it's going to equal that.
You got your voltage card on it? I can borrow it?
I promise I'll give it back.
Trust me.
Trust me?
Thanks, sucker. You go to your voltage card, okay, and you look on the back of that card, and it will tell you their angle sensor output at 0 degrees with your digital level on the boom is going to equal 0.4 to 0.6 volts, a little less than a half a volt. That will give you enough rotation on that indicator where you can take the boom below 0. You can also raise it up to 80 degrees, and you don't run out of live band. You don't lose your voltage signal and have that reading on the display drop into that line. Okay? So this is a very important part of the setup. Now in there we also have your anti-2 block slip ring, we already talked about, and your extension sensor back here. And note the extension sensor is mounted on a hinge point with a bolt. It has the large gear and a smaller idler gear, which sets up like a 4-to-1 ratio or something. And the smaller gear engages the gear teeth on the hub that's molded into the hub of the reeling drum. Okay, so that's going to turn. In order to set this extension voltage, you're going to pull down against the spring. See that spring loaded? Pull down against the spring, wind that thing clockwise until it stops. And you're either going to click or drag like we talked about on the clutch yesterday. And just make sure the clutch is working. Bring it back exactly a half a turn. Exactly a half a turn. And then when you measure the voltage that shows on your card at 0.15 to 0.35, that will set up the 0 point for your extension, okay? That sets up the point. Once you go through the calibration process we're going to go through, it's going to set up the point where the computer starts calculating boom length. It starts following the signal, okay? So that's why this card's important. This is your setup guide for anything 586. I don't care what it is. And then you have your terminal strip underneath. The terminal strip is an ideal place to go to find out whether the system's healthy or not, okay? If you're having any kind of sensor problems, if you pop the lid off the reeling drum, and it's only 12 screws, my God, and go right to the terminal block, and you can test your voltage output, your drive voltage for your sensors, and all of the outputs from your sensors, and troubleshoot your anti-2 block system all in one stop here. So there's no need for you to pull the lid off the computer and go probing around in there at this point. As long as you got your voltages here, you're working with a healthy system, so you can zero out your sensors and calibrate it and go home. So remember that terminal strip. The 2-block switch, this is the 2-block switch that Terex uses on their boom trucks, and they put it on a little swiveling bracket. And I don't know, to me it looks like a bumblebee riding an ant, but this is what they wanted to put on there. It's the same switch that they use on their RTs too, so that probably has something to do with it. But this 2-block circuit, see here we have the counterbalance weight, the terminal strip, the magnetic reed switch, and this circuit, this is the schematic for that circuit. And basically, other than measuring the voltage patterns, there's not a lot you can do with this because the voltage signal setup is buried in the manufacturing process of the board. The board contains a resistor network in there, and there's a 10-volt power supply. Remember the 3 little power supplies I showed you on the board a while ago? One of those is 10 volts, and that's supplied to this function kickout system, and it brings a certain voltage pattern out through the drive side of this, takes the drive out to the switch, and brings it back. If the switch is made, that signal comes back, goes right back into the computer. It's measured again to find out, you know, if it maintains this voltage pattern. And if it doesn't, it's an alarm condition. If it does, you know, you're safe. So what's that voltage on that? If that system is in proper working order, you're going to see a voltage coming back of 5.5 to 7.5 volts. Okay, and usually that signal is right on. You know, it's going to be there. So that's your 2-block circuit on this. Other places to check, of course, includes the collector ring. Is a place where you could have shorts or something. Probably the best thing to do is go inside the computer and get on the 2 terminals in there, for the brown and the black wire, and just make a jumper wire, cross it over inside the computer, and you'll know right away if the computer's good or not. You know, then you can chase out the short easily in your wiring. That just takes a little jumper wire. So, going into the calibration process. Most of you probably heard the terminology of fast cal. And what we do in this calibration process, of course, we need our tools, our digital level, our tape measure, the digital voltmeter. And of course, before starting the procedure, we need to have that crane set up in a safe position for extending the boom, because you're probably going to have to extend that boom fully, so you want the thing to be stable. It's recommended that the crane be configured with no stowed or erected jibs and a single part of line. This is not compulsory on the 586 system. On the 585, in that calibration process, you had to take the jib off, and nobody liked to do that, and I don't blame them. That's a lot of work, okay? So you can leave the jib on in a stowed position if you make sure that it's noted in the crane setup, okay? Because here's what happens if that isn't set up properly in your crane setup. The system looks at that and it sees all that extra load out there, and it says, gee, I don't know what this is, so it must be hook load. So bam, it goes on the hook. If you press the button and put that into the crane setup, that brings in the weight of the jib and the geometrical location of that jib and takes that into consideration and cancels it out, okay? So it's very important that the operator setup is done correctly for this. So getting into the calibration mode, and again, this doesn't matter if it's a Manitex or a Terex or a Broderson, you know, whatever kind of crane it is that has this 586 system. You're going to get into the calibration mode the same way. The way to get into the calibration mode is after the machine is set up. If you're in a setup mode and any of these numerals are blinking up here, you can press these 2 buttons all day long and it'll never go into calibration mode. So it has to be set up and ready for operation, and then you press and hold the up arrow and the setup buttons simultaneously, holding them in. It'll take about 8 to 10 seconds for that to take effect, and the unit will drop into the boom angle 0 calibration mode, okay? Now you are into a calibration mode where you can change things, so you need to be careful what you leave. This is all very user friendly. If you screw up and misset the 0 point, you can reset it. You can do it 1,000 times and it will overwrite every time and come out right, okay? So you just need to make sure you get that level on top of the boom, get that boom at exactly 0 degrees, and then when you press the setup button in this mode, it's going to make this angle equals agree with your level. It's going to zero it out, okay? So here we go, we got our boom level, our digital level up here. We're checking for agreement. If we don't get agreement, press the setup button. It will make the two tools agree. Now, how many of you ever got one of these in a bucket where the owner decided, well, hell, I can fix this thing, so he starts tearing shit off of it. Next thing you know, he's got all the pieces in a bucket, and he says, oh, gee, I need to take this over to Grub and let him fix it, right? So you get it in a basket. You can still set this up. Using your digital level, you can salvage it for them and go in and loosen the pot and reset the voltage pattern on it and get a perfect 0 out of it. You can still do that. And this procedure here tells you exactly how to do that, okay? I will caution you this, if you're gonna rotate the pot, you need to make sure that alignment is present. I showed you where the little arrow aligns with the crack on the bracket. You need to make sure that that's set right, because they like to fiddle with that stuff too. And then you just loosen these screws just enough to move the pot. It's very, very sensitive. Really hard to get it on track. But you know, you have that voltage tolerance you can use, and then with the softwares today, you know, you can push a button and 0 it and make it agree. So there's your correction. So after 0 on the angle, we move on to the extension 0 calibration, the next step. You can see it reads extension 0 on the screen. Extension equals some number, okay? This is the point where if everything is normal and you didn't get it in a bucket, you're just gonna take and rotate the sensor all the way back until it stops, bring it back a half a turn, which will bring the sensor online, and then press the button to 0. So you will get extension equals 0. That way the system will start counting from there for the extension length. This is just a little long form calibration procedure here that makes sure you're turning the sensor in the right direction and stuff, and giving you those instructions one at a time. You can measure the voltage if you're in doubt about voltage or power supplies or anything like that. You need to measure those voltages. Go to the terminal strip, measure between the blue and the white wire, and make sure you can get this 1/4 volt. Now the reason you have the 1/4 volt is so that the computer sees some kind of voltage pattern and knows that the cable hasn't been broken and reeled back and shut the sensor clear off. So if the sensor's at 0, the system doesn't recognize 0. It's gonna drop into dash lines and say, well, we've got an A04 here, right? You're gonna get an error code, okay? So you have to have that little 1/4 volt gap in there. So after you do all this, if you go in and you hit the setup button, and it's going to 0 the extension. It's going to say extension equals 0. Now, setting spans is a little different. And on the 586, we do this by a process called trims. And the way this is set up, when we do the OEM calibrations at the factory, we actually take a tape measure and take the prototype machine and we hand measure the boom extension and the boom retract. We hard code those dimensions into the software, into our 5 charts file, so those are remembered. We also subtract the extended length or the retracted length from the extended length and come up with a span number, and then we hard code that span number into the software also. So then we go into a process called extension trim, and you raise the boom up and you take that out until you hear the cylinder clunk when it physically reaches the end of the stroke. Then we know we're at the right length, okay? There's a little allowance there for tolerances and cable slag and stuff like that you're gonna have. And it's going to, when you press the trim button, it's gonna trim it to the exact length that we measured, okay? So there's no numbers for you to enter and stuff like that on this. But it is important that you know what you're doing here and realize how that span number's arrived at, okay? So, let's talk about angle span. Angle span is the same kind of procedure, except we're gonna use a specific angle. After we set our zero, we're gonna use a specific angle, like exactly 60 degrees on your level. Okay, we're gonna raise that boom up to exactly 60 degrees, and probably you're gonna have some disagreement between this angle equals on your calibration process. And when you press the setup button, it's gonna force the system to say, okay, it's 60.0. Okay, so it's gonna put that number in for you and say, okay, we're at exactly 60 degrees. Okay, pressing the up arrow always takes you to the next procedure. Okay, so setting the span for the extension is what we just talked about. I kind of got out of line there, didn't I? Setting the span for the boom extension. Here's some more facts about the boom extension. When you arrow up and go to the next menu, you're gonna get the angle first, okay, the angle span. So you go to this length trim module, and what's gonna show in the window here is the retracted pin to pin of the boom, okay? So if you're trying to match that up, you're gonna have to measure it pin to pin. So you start extending, this is gonna show the maximum extension of the boom. And again, you know, if you've got a BT 4792 that says, okay, I got a 92-foot boom, your span is probably going to say like 91.5 or something like that. It's probably not going to agree with the sales literature, and that's okay because it's a measured, hard-coded length. So once you extend that out and it hits maximum length and you press the button, it's going to transform that number to the recorded measured length, like this, okay? It says OK equals trim. That's set in there with about a foot tolerance. So you, and this is a warning too, this will probably show up, this OK equals trim, before you hear the cylinder bump. So make sure you go clear out until you hear that cylinder bang the end of the stroke, because that's the best measuring tool you got, really. Okay, press the button, it'll trim it to length. Okay, some other things that we have in there is the winch rope data. Most, in fact, all of the Terex cranes, I don't know about others, have a standard and a spin-resistant cable on them, and it has different braking strength limits. So you need to set that limit. A lot of times your customer may want to come in and change to a spin-resistant cable. You go into your calibration mode and go into rope limit setup, and pressing the setup key will change the limit, okay? So then you menu up, and it will take you back out to the operate mode. That's changing the rope limit. Now, this kind of trips some people up, especially when Terex screwed up and didn't install the jibs in their software, because there's a software setup procedure in there for calibration, installing a stowed jib configuration. When the software is first put in, it's probably going to default to main boom, no jib extension, like you see on the screen. this is the last step in the calibration procedure, and when it comes up, it's gonna say jib selection on it. If you press the setup button, this will start blinking. It'll start blinking. When it does, if you use the up arrow key and start rolling that, it will take different jib setups. It'll say 26-foot jib, 26 to 46-foot jib, or whatever it is. And when you reach the one you want, you press the setup button again, and it will nail that procedure in there. And when you go to the operator setup screen, you'll be able to call it the jib. It kind of causes some havoc the other way, because when the operator presses it, he can't get to the jib. Okay? I used to get panic calls on that.